Now, our next step is how to name ionic bonds. So we just talked about what is it? What does it mean to be ionic? Now, how do we name them? We're going to start with our very simple ones, namely our atoms from the first 3 groups, well, most of the 13th. We're going to skip all of these transition metals right now. So we're dealing with 1, 2, 3. These are going to be our cations. So they're positive. One atom is always a positive, and one atom is always a negative. Now, this periodic table has given you something very useful. It's already named your anions. What you'll notice is this periodic table has changed your names to have an "ide" at the end. Nitride is not the name of this element. It's the name of the anion. N is nitrogen. O is oxygen. F is fluorine. Phosphorus, sulfur, chlorine. Arsenic, selenium, bromine. Iodine, and tellurium, and acetine. So this is helping you tons because it's already changed your names to "ide." Because that's our first step if you're just given a regular periodics table. So we're going to be talking about naming salts. Salts are ionic bonds that dissolve in water. Salts are ionic bonds that dissolve in water. So you have to have, I put bonds. I meant compounds. Ionic compounds that dissolve in water. The bonds also dissolve, but so we can put salts in water and they all disappear. Okay? We're going to be naming them today. The first thing you need, write the anion name. Cation name. Sorry. Write the cation name. Second step, write the anion and end it with "ide." Anions are negative, cations are positive. And if it helps you remember, cation. There's a giant plus in the middle of your T. Cation. Plus ion. It's a plus ion. Now let's do an example of this. Let's say you have 2 materials reacting. Sodium, Na, and chlorine, Cl. This is common household salt. You eat this every day. Usually it's had some iodine sprinkled in, but that's the government giving us free medicine. Thanks, government. So we have Na and we have Cl. Now, if we remember our valence electrons, Cl has 7 valence electrons. Na has 1. So when they become ions, they're going to combine by Na losing its electron. So Na will lose its electron by electron. Now once Na has lost its electron, it becomes positive. Na positive. Now where did the electron go? It went to chlorine. Chlorine now has 8. It is now negative. So now we can have this ionic bond, this bond between a charged positive molecule and a charged negative molecule forming together. So now we have NaCl. Now how do we name it? Well, we go to our periodic table. We go, okay, Na, ooh, it's called sodium. Let me put sodium here. Go here and say, okay, chlorine, it's chloride. And that's it. Let's talk about a little bit more complicated one. We're going to do both. Let's say we're going to name it, and then we're going to give the formula. Then we're going to give the name. So let's say we have a fun little element, calcium, Ca. Calcium is in the second group. Calcium is in the second group, so it has 2 electrons. I'm going to have it bond with a fun little element called nitrogen, N3-. Nitrogen is in the 1, 2, skip all the transition metals right now, 3, 4, 5. It has 5 valence electrons. 1, 2, 3, 4, 5. Now, what are their charges going to be? Remember, this is the octet rule. All atoms want 8 electrons. All atoms want 8 electrons, no matter what. So calcium is going to give up its 2. So here we have calcium giving up its 2. Yay! It's going to give one to nitrogen. Ooh, and then it's going to give another one to nitrogen. So calcium is done. Calcium we now have is Ca2+. We lost 2 electrons. That means since electrons are negative, you're going to have a positive 2 charge. Now nitrogen, 1, 2, 3, 4, 5, 6, 7. Uh-oh. All atoms want 8 electrons. This only has 7. So nitrogen is going to go out searching, looking around for other atoms to give it electrons. Well, in this solution, we only have other calcium ions, and we only have other nitrogen ions. So it can only find stuff from calcium. So we're going to have another calcium come in. Now calcium has still the same amount of electrons to give, 2. So it's going to give up as much as it can. So it's going to give up this 1. And nitrogen now has 1, 2, 3, 4, 5, 6, 7, 8. It's done. It's charged. It's charged. It's going to take 1, 2, 3 new electrons. So its charge is going to be 3 negative because it has 3 extra electrons. 3 negative. However, now we have this little calcium just floating up out with an extra electron. Okay? Is not happy. I promise you 1 electron is going to react like that. But it can't react with other calcium ions. It's not going to be happy if it reacts with another calcium ion because calciums only have 2. They want to give them away too. They have 2. They don't want these 2. They don't want an extra one. 3? No, thank you. So they're going to find another nitrogen. And this new nitrogen only has 5. and calcium is going to be like, hey, nitrogen, come here, come bond with me. And it's going to give up its electron, boop, and be happy. So now I have Ca2 plus, N3 minus, another Ca2 plus is done and happy, and we've started on another N. So we need to complete. So nitrogen goes out and looks for another calcium. It says, okay, here's a calcium, and calcium has, I have 2 to give. Let me give them up. So calcium gives its 2 to nitrogen. Boop. And now we have a complete 8. 1, 2, 3, 4, 5, 6, 7, 8. We have another 2. And we have used 1, 2, 3 calciums and 1, 2 nitrogens. And both nitrogens are N3 minus. All 3 calciums are Ca2 plus. This is your final construction. And those salts are crystalline, so this will form a crystalline structure. So you might have like a Ca and then an N and then another Ca bonded and then another N and bonded to this Ca, and then you have another Ca up here. So ignore that. So you have some sort of crystalline structure being formed. Crystalline is to look like a crystal, so salts are crystal. Now that's a lot. But let's talk about naming it and then find an easier way to do it. So to name this, we have Ca. So we go over here. Ca is calcium. Calcium. We go to N. N is nitride. And our formula will be 1, 2, 3. 3 calciums, and 1, 2, 2 nitrogens. Okay, so that's you understand molecular. This is why this is this. Okay, now we're going to give you the shortcut. Our shortcut, the crisscross rule. Crisscross applesauce. Let's just do Na again. Not Na. N and C. Ca. So calcium, we know from this chart, it's in the second group. All of the second group elements, which are called the alkaline earth metals, all of these have 2 valence electrons. They'll all be 2 positive, so they all react very similarly. So I know Ca is 2 plus. I know without drawing any of those valence electrons. I know that N is 3 minus. So all I have to do is take the 2 from the Ca and give it to the subscript of N. I take the 3 and drop it to calcium. I will rewrite this Ca3N2. Let's check if that's the same as what we got over here. And it sure is. Ca3N2. Without all of this crap. So take the all you have to do is take the charge and switch them and put them on the bottom to get your answer. This works with all of my salts. So let's say I have magnesium fluoride. Magnesium is Mg. It's a 2 plus. Chloride is Cl, 1 minus. You do the crisscross, you're left with magnesium, 1 Cl2. Now, because everything times 1 is itself, I'm just going to rewrite this real quick as MgCl2. Okay, now let's talk about a kind of an exception. Exceptions. If you have atoms with the same charge, so let's do aluminum with 3 plus, and we're bonding it with phosphide with 3 minus. Al3 plus, P3 minus. When we do our crisscross rule, we're going to be left with Al3, P3. Now, unfortunately, this is not the answer. We are going to have to simplify it. Since there's 3 aluminums for every 1 phosphorus, there's 3 aluminums for every 3 phosphorus, I can just do 3 divided by 3, and I get Al1, P1, or AlP. So we're going to simplify it. Let's do another simplification. I think this one. No, we can't do this. Let's do germanium. Okay. So germanium is a 4 plus. Let's put GE. GE2 plus. I'm going to bond it, or 4 plus, sorry. Let's repeat. GE4 plus. I'm going to bond it with sulfur at 2 minus. Now, when I do the crisscross rule, I'm going to get GE2S4. Now, again, this is not correct. You're going to have to simplify it, and you simplify it by its smallest number. So we're going to divide by 2. 4 divided by 2. So GE2 divided by 2 is 1, and S4 divided by 2 is 2. So we're left with GES2. And that's how you name simple salts.